Hi all. Today we'll be discussing the LeetCode problem of the day, magic squares in a grid. So a grid is a magic square if it's of 3 cross 3 size, and all the numbers in the grid should be distinct and from 1 to 9. Also, the sum of the rows, sum of the columns, and sum of both the diagonals should all be the same. If all the criteria are matching, then it's a magic square. So you're given a grid of size row and row into column of integers. You have to count how many 3 cross 3 magic square subgrids are present in this grid. Also given that while the magic square should be formed only from numbers from 1 to 9, the grid can contain numbers up to 15. Now let's look at the first example. So in this grid, it's of size 3 cross 4. We can form two 3 cross 3 grids. This is the first grid and this is the second grid. Now we'll look at the first grid, which is this. Sum of the first row, this is 15. Sum of the second row is 15. Sum of the third row is also 15. If we check the sum of the columns, this is also 15, 15, 15. If we check the sum of the diagonal, it's 15, and sum of the other diagonal, this is also 15. Also, if we check the numbers, so all the numbers from 1 to 9 are present. So this is a magic square. Now we'll, if we check the other 3 cross 3 grid, here also we can see sum of all the rows turns out to be 15, and if we add the columns, they are also 15. But if we check the sum of the diagonals, this diagonal has a sum of 6 and this diagonal has a sum of 12, and all the numbers are distinct from 1 to 9. So all the properties are matching except the diagonals, which sum is not matching with the sum of the rows. So this is not a magic square. So in the first example, the output will be only 1. If we check the second example, the grid is of size 1 cross 1. So in this grid, we cannot form a grid of size 3 cross 3. So we don't have any magic squares. So the output will be 0. Coming to the constraints, the row and column size will be from 1 to 10. And the elements in the grid can be from 0 to 15. Now let's go with the approach. So you're given a grid, and in that you have to iterate on all possible 3 cross 3 grids and check whether they are satisfying all the conditions for it to be a magic square. So in this, if you start at this point, this is your 3 cross 3 grid. And suppose if you start at this point, then this is your 3 cross 3 grid. So on this, we'll see what all starting points we have to iterate on. So coming to the row, you can start at here, you can start at here and here. So at this starting point, this is the last starting point you can iterate on the row. Because if you start at here, you can't form a 3 cross 3 grid, which is starting from here. That's why if you end here, you can form a 3 cross 3 grid. Similarly, for the columns, if you start at here, this is a grid you can form. And if you start at here, this is the grid. And if you start at here, this is the grid. And finally, if you start at here, you can form a 3 cross 3 grid. After that, if you start anywhere here, then you again can't form a 3 cross 3 grid. So that means you can't start your 3 cross 3 grid anywhere between these points, which is basically the last two columns and the last two rows. So when you iterate on this grid, you have to start from 0, I mean the row, and the row should go until row minus 2. Similarly, when you iterate on the columns, you start the columns from 0 and the columns will go till column minus 2. So once you have the starting point, this starting point will give you this 3 cross 3 grid. And in this grid, you'll check first all the rows have the same sum and columns also have the same sum and also the diagonals. Once the sum criteria is matching, you will also check whether all the numbers in this have 1 to 9 and all are distinct. Then it is a magic square. So you'll just count how many magic squares are present in the entire grid. So let's quickly code the approach. So first let me take count as 0 and also the row and column length, grid dot length. column will be grid of 0 dot length. Now, like we discussed, we'll start I from 0 and I is less than rho minus 2. Or to be clear, we can say I plus 2 is less than rho. Because for a 3 cross 3 grid, your first row will be I, next row will be I plus 1, and the last row will be I plus 2. So the last row, which is I plus 2, should be inside the bounds. We have I plus plus. And similarly for the columns, j equal to 0, j plus 2 less than column, and j plus plus. So here we'll just make a function. If check, we'll pass the starting points I, j, and grid. If check is true, then we'll just count the grid. Check is true, then it's a magic square, so we'll just count it. And at the end, just return count. Now let's quickly fill up the check function. I, j, and grid. So first of all, let's take the sum of the diagonal. Let me just draw the grid for reference. So this is your I and this is your j. Now you want the sum of this diagonal. So let's say magic sum will be grid of ij plus, copy this, I plus 1 j plus 1 plus I plus 2 j plus 2. So this is ij, this is I plus 1 j plus 1, I plus 2 j plus 2. So you'll get the sum of the diagonal. Now all the sums, sum of all rows and sum of all columns should be same as the magic sum. Then only the grid will be magic. So you got the first diagonal sum. Now you'll count the sum of the second diagonal. So second diagonal is this, which is I plus 2j, I plus 1j plus 1, and I j plus 2. So we can just copy this and modify. So first is I j plus 2, the same, and here I plus 2 and j. So once you got the sum of the second diagonal, you'll check if sum is not equal to magic, then you can straight away turn false. No need to check the other rows and columns. So now once the other diagonal also has the same sum, now let's check for all the rows. The first row, second row, and third row. So for the rows, we have to iterate on the column because that's what is changing. Sorry, we have to iterate on the rows. Let's have row equal to I, then row less than equal to I plus 2, plus plus. For the sum, it will be row and j, row j plus 1, and row j plus 2. So that means first you will calculate this row, and in the next iteration the row increases, so you'll get the sum of this row, and finally the last row. So at any point, once you get the sum, you'll again check if sum is not equal to magic, then straight away you'll return false. And the same thing you can extend it to get for the columns. So column will be j, column less than j plus 2, and column plus plus. Here I, column plus 1 column, and then I plus 2 column. So this indicates first time column is j, so you'll get the sum of this row, I mean this column. Next column increases, So you'll get the sum of this column and finally the last column. And similarly, if sum is not equal to magic, you'll straight away return false. If none of this, if all the conditions are matching, you will return true. Also, there's one more condition to check, that in the magic grid, all the numbers from 1 to 9 should be present and no number should repeat. So for that, let's just take a Boolean array, visited. Let's take the size as 16 because the numbers in the grid will be from 0 to 15. So if we take size 16, we can fit, the index will be from 0 to 15. So we take the grid again. So all we need to do is when we need to put all the numbers in this 3 cross 3 grid in the visited array, and we just need to check whether all the numbers from 1 to 9 are present. So instead of iterating again, we can use one of the for loops, because in this for loop we are iterating on all possible numbers. So to utilize that, we can just say that visited of this to yeah. So in the first iteration, all these numbers will be marked in the visited array. Next, all these numbers, and finally the last 3 numbers. So after doing this, all the 9 numbers are marked in the visited array. So now we'll just iterate um, from 1 and sum is less than equal to 9, sum plus plus. So at any point, if visit of num is false, straight away return false. So if all of these checks are passing, so none of them returns false, at the end you'll just return true. And if it is true, then you'll just count it. Okay, this is magic sum. Same thing here as well. Yeah. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So here we are running 2 loops, which will have overall complexity of order of n into m. And inside that, we are running a check function. So let's quickly check the complexity of the check function. So this is constant, here also constant. Here we are running a loop, and this loop will run only 3 iterations. So this is also treated as constant. And similarly, this loop is also constant. And here we are just iterating on, we are iterating from 1 to 9. So this is also constant. It doesn't depend on the grid size. So we can say overall, the time complexity of the check function is constant. So the overall time will be order of n into m. Here n and m is a row and column length, and both are up to 10. Now coming to the space complexity. Space complexity is again, we are only creating a Boolean array, which is of constant size 16, and this doesn't depend on the row length and column length. So space complexity is also constant. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.